SAT 22 for the week of 17. Let's take a look at our question. For the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 is equal to 14, which of the following equations defines q? And you can see that we've got some choices of some exponential equations. How did we do on this? Well, we said at about 78.9%, nearly 80% of us chose marigold. That's what I'm going to call that. Answer choice C, which was in fact the correct answer. The other ones were kind of pretty close to evenly split. And we said pretty clearly that this was a medium question, just like all of them. Well, here, let's go ahead and take a look at the solution. Let's dive right in here. So the first thing that I would suggest doing is just plugging in the point that they gave us. So this q of 0 is equal to 14. Of course, that just means the ordered pair, 0, 14. You plug in 0 for your x, 14 should be the answer. So just remember this. Whatever your base value is and you raise it to the 0 power, that should be equal to the number 1. Well, there's one exception to this, and that's 0 to the 0 power, and that is undefined. But anything else you raise that thing to the 0 power, you're going to get the number 1. So that's significant because you can, without a calculator, check and eliminate a couple of these answer choices. So for example, if I plug in 0 right here for my x value, this is 14 to the 0 power, that's going to be the number 1, and it's just going to be multiplied times 0.55. So basically this is going to be 1. You get 0.55. That is not the number 14, so this guy goes away. Boop. Likewise, so does B for the exact same reason. Again, if I plug in a 0 right in here, this goes to 1, and my answer is 1.45. Take a look at answer choices C and D. So here, whenever I plug in a 0 for each one of these exponents, these go to 1. Whatever this base is goes to 1. And I'd be multiplying that times 14 in both of those cases. So we've got a check mark for these last two. So now we got a 50-50 chance in order to figure out which one of these we should pick. Okay, now you can look at this and going, this thing is getting smaller. It's getting smaller because it is decreasing, as it says right there, decreasing. And which of these bases makes something smaller? Well, you may remember from Algebra 1, the difference between exponential growth and exponential decay. So growth happens when your base is greater than 1, and decay, that's getting smaller, happens whenever your base is less than 1. Well, there you go. There's your answer choice. It's answer choice C, because it's the one that has a base that's less than 0. Now, let me kind of dive a little bit deeper into this and explain some of the math that's going on, especially with this exponential growth and exponential decay. So it does give us this statement here that q of x, that's our y value, is going to go down by 45% for every increase in the value of x by 1. So let's start with this ordered pair right here. I'm going to increase the x by 1 plus 1. So of course that means that my next x value is going to be 1, comma, and now this thing is going to go down by 45%. And we've seen in a previous one of these questions, when we're dealing with percentages, what we've got to do is take our number, 14, multiply it times our percentage written as a decimal, so 0.45. But then whatever that is, we have to take that away from the original value. So it's just like a discount on some clothing, 10% discount. You take the 10% of the price, and then you have to subtract it from the original price. So that's kind of what we're doing right here. And I'm actually not even going to work this thing out. I mean, sure, you can pull up a calculator and you can type that in and get what that result is supposed to be. However, what I'm going to do is notice that there is a common factor of 14 here. So, like, you could just use the distributive property and factor it out. So 14, open up parentheses, and if I divide this by 14, I get 1. And if I divide the second term by 14, I get 0.45. And now let me just simplify this as 1 minus 0.45 gives us 14 times 0.55. That looks really familiar. That is, of course, that answer choice C again. So in general, what this equation looks like for exponential growth and decay, which you guys will tackle extensively in Algebra 2, is y is equal to some starting value, which I'll call A, times 1 minus, or plus, I should say, the rate raised to some sort of power. And this plus sign that could be minus, it's dependent upon what your R value is, the rate, written as a decimal. So as an example, let's say your R is equal to 50%. Well, you just have to understand, is this getting 50% bigger or is it getting 50% smaller? Let's say it's getting 50% bigger. That means I'm going to be adding that 50% to whatever my starting value is. And so my equation would become y is equal to some starting value, 1 plus 50% is going to be a 0.5, so 1 plus 0.5, of course, is 1.5, and then raised to the x value. And then you can see, just like we mentioned before, this thing is greater than 1. This is an example of exponential growth. Okay. Now then, one last one. Let's say that instead, this thing was getting smaller. It was decreasing by 50%. Well, then that means I'm taking it away. It's a negative. So in this case, my equation becomes y is equal to my starting value, 1 minus 0.5 times x. 1 minus 0.5, of course, is just 0.5. And now you can see that this base value right here is definitely, let's change that. Oh, yeah, it is less than 1, so you've got yourself a decay. So let me just show you some graphs on Desmos. This is certainly not one that you necessarily have to use Desmos or your graphing calculator on, because you can kind of just think your way through these by plugging in the numbers that you had. But I will, just so we can see the shape of this and then also get some kind of calculator skills under our belt. Let me side by side this because I'm not going to remember what those equations are. Okay, so I'll zoom in and let's say that I had no clue about all these like exponential properties, so I just plug in my equation and I can type it in function form, which I totally recommend that you do, and you'll see why in just a second, is equal to 0.55, put the parentheses, arrow out of the parentheses, and then the A to the B is the button that you have to press for the exponent if it's not just squared. Okay, and so you can see the graph of this. This is what a classic exponential growth graph looks like, but it is super steep because the base here is 14. And now on the second line, what I'm going to do is I'm just going to plug in, I'm just going to plug in my 0. And the benefit of having an f function notation is that you can just do function evaluation as q of 0, and you can see pretty clearly that it's not equal to 14. So at this point, what you can do is you can just go up and you can just change your each one of your values pretty quickly and check the next answer choice. So I got 1.45. Boop. And you can see that that is also not 14. Okay, so then you can change this to 14 out here. 14, and then inside here was 0.55. And that one is, whoa, no, that's 0. What? How about 0.55? And now you can see that the graph is actually pointing the other way, which is exponential decay. So on this little graph here, you can see these x values. They're getting smaller and smaller. They're getting closer and closer to 0. And you remember that it never actually touches 0. And the x-axis functions as what we call an asymptote. All right, so that should conclude this video on this week's SAT question.